NASA and SpaceX are going to be working together to deflect an asteroid. It's called DART, the Double Asteroid Redirection Test, and it will take flight placed on top of a Falcon 9 rocket in June of 2021 from the Vandenberg Air Force Base in California. And now the mission of DART is to smash a satellite into an asteroid's tiny moon in order to deflect it off of its orbit. And it sounds exciting, but if the mission fails, it would result in derailment of NASA's kinetic impactor technique. However, if it's successful, it'll provide very crucial data that will inform its deployment against an actual asteroid that's approaching our planet. So they're going to send a probe up, they're going to hit one of these asteroids' moons, deflect it out of the orbit, and this is the first test case. This is the first time that they're going to try this out. So if it's successful, this is going to be great. It's going to send us data that will tell us that, hey, this is possible. We can do it on a bigger scale, and we can do it for something else, not just a tiny moon. And they're going to smash into this moon going at around 13,500 miles per hour. And it's going to reach the target in 2022, and it'll be 11 million kilometers away from Earth. And this is really cool because this is a different kind of mission for SpaceX. It's not just transporting humans and cargo to and from the International Space Station. This is a scientific mission, and this could open up doors to NASA and SpaceX working together in different forms in the future. And this mission is going to be relatively cheap in the grand scheme of things. It's going to be about $69 million, including the SpaceX launch and the full mission. So $69 million compared to, billions of dollars for a Mars rocket. It's relatively cheap in that sense. It's still a lot of money, but for space, it's not bad. And the asteroid they're going to go after is called Didymos. It's provisional destination 1996 GT. It's a sub-kilometer asteroid, and it has a binary system classified as potentially hazardous asteroid and near-Earth object of both the Apollo and Armor group. And this is really cool. So there's a Hera spacecraft, which is an ESA spacecraft, and its destination is the same asteroid as NASA and SpaceX's mission. So they're working together, NASA and ESA, on this mission. And it's really cool because ESA's spacecraft is going to try to fly itself there. So it's going to be autonomous. It'll be flying to the asteroid by itself, and with new techniques that ESA has developed. Not only does this spacecraft have autopilot, it can dodge space debris. There's something coming at this thing, it'll move out of the way. So it'll take flight alongside NASA's Asteroid Impact and Deflection Assessment Mission spacecraft. The ADA mission would focus on NASA's Double Asteroid Redirection Test, the DART test, as I spoke about before. It's basically a defense system for Earth, and it'll redirect asteroids. So if ESA and NASA can work together, we can send out autonomous satellites to these asteroids, destroy them, move them out of the way, whatever we need to do to them. And, we're going to protect the Earth with these kind of technologies. It's kind of incredible. And this is where it gets really, really cool. So the Hera spacecraft, it's ESA spacecraft, it's going to detach from its launch vehicle, and it's going to orbit around the asteroid, right? So it's going to be orbiting around the asteroid, and then the NASA probe is going to do its thing. It's going to deflect the moon of the asteroid, and ESA's Hera spacecraft is going to watch everything autonomously. And then it will swoop in, and it'll examine the crater after the collision. So it's going to give us data about the initial collision from NASA spacecraft, and also after the spacecraft does its thing, and the aftermath of the collision. And this is self-driving, like a Tesla. Well, not driving, I guess. Flying would be the best word for it, but it has similar systems to autonomous vehicles on Earth.